Welcome to This Explainer. Today, we're unpacking an absolutely incredible natural phenomenon that's completely reshaping how we fight climate change. You know, we hear a ton about reducing emissions or planting terrestrial trees, but today, we're looking at a powerhouse solution that exists right at the edge of the ocean. It's a real game changer that brings biology, climate science, and coastal resilience together into one seriously fascinating story. Let's get into it.
To kick things off, I want to ask you a question that kind of flips how we normally think about carbon storage. When we picture the lungs of the Earth, our minds almost automatically jump to vast, sprawling rainforests, right? But what if the true heavyweights in the fight against a warming planet aren't actually on land at all, but are hiding in plain sight right along our coastlines?
So, here's our roadmap for today. We'll start with the blue carbon concept, move on to mangroves as coastal guardians, explore their climate resilience superpowers, discuss the threats we face, and finally, wrap up with conservation and restoration solutions.
Okay, Section 1, the blue carbon concept. Now, according to the IPCC, blue carbon refers to biologically driven carbon fluxes and storage in marine systems that are amenable to management. Now, that phrase, amenable to management, is absolutely crucial. Sure, there's a massive amount of carbon way out in the deep open ocean, but that's incredibly difficult for us to actually manage. So when we talk about actionable blue carbon, we're zooming in on very specific coastal ecosystems. We're talking tidal marshes, seagrass meadows, and mangroves. These are the ecosystems we can practically protect, restore, and manage ourselves.
And out in the real world, these vibrant, thriving mangrove ecosystems are just completely intertwined with local communities. You'll see traditional structures built right into the shallow waters, literally hugged by this dense protective canopy of green. This isn't just some isolated, untouched wilderness. It's a highly active, lived-in environment. These coastal forests provide immense value to the folks living right there, offering everything from essential building materials to vital nurseries for both local and commercial fisheries.
Moving right along to Section 2, mangroves, the coastal guardians.
Mangroves are, without a doubt, the unsung heroes of the natural world. They're these totally unique coastal forests that have figured out how to thrive where most plants would literally just perish. Now, because they absolutely cannot tolerate freezing temperatures, they dominate the equator. You'll find them stretching across tropical and subtropical latitudes, places like Southeast Asia, the Caribbean, the African coasts, Australia, and South America. They act as this vital living bridge right between the land and the sea. Because they sit smack in the middle of the intertidal zone, they are perfectly positioned on the front lines of the coast. Think about it. As the tide rolls in, their complex, tangled root systems are partially submerged, and as it rolls out, they're suddenly exposed to the air. Surviving in that extreme, dynamic environment takes some serious biological resilience. And they aren't just passively sitting there either. They are actively shaping the coastline and acting as a safe haven for an incredibly diverse mix of marine life just beneath the surface, stuff like fish, shrimp, sponges, and corals.
Which brings us to Section 3, superpowers in climate resilience.
So, what exactly makes them superheroes? Well, their biological abilities basically break down into two distinct world-saving categories. On one hand, we've got mitigation. Mangroves are out there actively pulling carbon dioxide right out of the atmosphere through photosynthesis. And they don't just store it in their leaves, they bury it deep down in the underlying mud and sediment. Then on the flip side, we have adaptation. As global temps rise and extreme weather ramps up, these forests act as a literal, physical barrier. Their massive root networks lock down the soil, fight off erosion, and just absorb the brutal impact of storm surges and cyclones. They're literally protecting our coastlines while simultaneously healing the atmosphere. How cool is that?
And all of that unique biology results in an absolutely wild statistic. Mangroves are highly efficient carbon sinks. In fact, they're one of the most carbon-dense ecosystems on the entire planet. Even though they cover way less global surface area than terrestrial rainforests, their carbon burial rates are just off the charts. You see, the sediment they live in is usually anaerobic, meaning it's starved of oxygen. Because of that, organic matter breaks down super slowly, allowing them to pack away massive amounts of carbon deep underground for centuries, as long as they're left undisturbed.
But, as you might expect, we need to talk about Section 4, the threats we face.
Every hero's journey has some dramatic tension, right? Well, take a look at this number, 2 to 7%. That staggering figure represents the estimated annual global loss rate of these vital coastal blue carbon ecosystems. To really put that into perspective for you, we are currently losing our coastal guardians faster than we're losing tropical rainforests. And the kicker? When these ecosystems are degraded or destroyed, they don't just stop capturing carbon. All that vast, ancient carbon they've been storing underground for centuries gets released straight back into the atmosphere, which just accelerates the exact climate change we're trying to fight.
So what's driving this? Let's quickly run through the direct human threats causing this rapid decline. In places like Southeast Asia, which actually sees the highest rates of mangrove loss globally, it's heavily driven by agricultural expansion. But across the board, we're seeing massive deforestation for charcoal production, lands being cleared to build aquaculture shrimp farms and salt ponds, and just rampant urban sprawl as coastal cities keep expanding. Add in the toxic industrial and agricultural runoff polluting the waters, and you can really start to see the immense pressure they're under from our activities.
But human development isn't the only threat here. We also have to look at the climate impacts themselves. Scientists project that if our world warms by 2 degrees Celsius, we could see up to 87 centimeters of sea level rise by the year 2100. That is nearly a full meter of rising water. Now, historically, mangroves have been able to adapt to slow, gradual sea level changes by slowly building up their sediment. But a rapid rise of 87 centimeters, that threatens to just completely inundate and drown entire ecosystems.
And that brings us to a really tricky phenomenon known as the coastal squeeze. In a totally natural, undeveloped world, if sea levels started to rise, a mangrove forest would just naturally, slowly migrate inland to higher ground. Easy enough. But ironically, because we humans have built paved roads, concrete seawalls, and neighborhoods right along the coast, these mangroves are totally trapped. They're caught in this fatal squeeze. The rising ocean is pushing in from the front, and our hard, immovable infrastructure is blocking their escape at the back. They literally have nowhere to go.
Thankfully, there is some good news. Section 5. Conservation and Restoration Solutions.
The story absolutely does not end there. We've got some incredibly powerful allies in the form of nature-based solutions. Ecosystem restoration often starts incredibly small, with delicate, fragile mangrove saplings intentionally planted out in the thick, muddy sediment. It's a real proactive intervention of hope. And over time, that muddy little sapling can grow into a resilient, complex coastal forest. Actively replanting and rehabilitating these degraded areas literally brings these ecosystems back to life. Today, major initiatives like the Global Mangrove Alliance and the Bond Challenge are leaning heavily into these exact nature-based solutions to recover our lost carbon sinks.
But here's the thing. It's not just about planting random trees wherever we find space. It requires what experts call climate-smart restoration. Since about half of the world's mangrove forests live in cyclone-prone areas, restoration projects have to be designed with future climate impacts in mind. That means we have to specifically identify and select mangrove species that are highly tolerant to intense winds and storms. And, crucially, it means engaging local communities, educating folks, supporting sustainable practices, and making sure the very people who rely on these coastal ecosystems are the ones actually leading the charge to protect them.
I want to leave you with this final thought for today's explainer. We've seen firsthand how these incredible mangroves defend our shores, sustain local communities, and lock away massive amounts of carbon to help stabilize our global climate. If our greatest, most efficient allies in the fight for a resilient future